To the next slide.
All right.
5 minutes.
Okay. Hi, my name is Avishai. I'm a software developer at Deep Genomics, where we provide an AI platform for accelerating the development of RNA therapeutics. Today I'm here to talk about GenomeKit, a fast Python library for handling genomic resources. First, I'll go over the API, then I'll show a few benchmarks, and then I'll go over a few of the techniques that we use to achieve the performance. So first, a little bit of the API. We can see how we create a genome object, then we access one of the genes by its ID, then one of the transcripts by its ID, and then the first exon in the transcript, and then we print out the sequence for the resulting DNA. We access the exons interval, and here's something interesting. We can see all the exons relationships inside that annotation. So we can see that the exon is first in the transcript. We can access its coding sequence and its neighboring exons. So we just saw an interval. An interval is a basic building block in GenomeKit. It comes with a large variety of mathematical operations. It's very useful in the context of large collections of intervals where we can find and match. So in this example, we access the first exon in one of the transcripts, and we find all the overlapping exons for that exon on the entire genome. We can see a list of all those operations at the bottom. Variants are a first-class citizen of GenomeKit. Here we create an interval and get its DNA. Then we create a variant object and apply it to that DNA and quickly get the resulting DNA sequence. Data tracks, as you probably already know, are a way to store numerical scores or multiple numerical scores for every base pair on the genome. It's a very powerful tool in the context of machine learning. And now I'll show a few benchmarks that I ran on my laptop. I ran a few basic operations like getting a DNA sequence or reading annotation features, a VCF file. As you can see from these numbers, GenomeKit performs multiple orders of operations better than any of the libraries that I compared it to. I'll talk about a few of the techniques that we use in order to achieve this level of performance. So first off, obviously, GenomeKit is implemented in C++. That allows us to avoid using Python data types, which are kind of wasteful in terms of memory usage. We pre-build the files, so everything is indexed and very fast to access. We make sure that these files are as small as possible to minimize our memory usage. And finally, the files are really, really fast to open, and the reason is that the contents are just serialized C structs. So all you need to do is use mmap, and you immediately get a pointer to your data structure. And if you compare this to like other serialization formats, you normally have to parse the file, then you need to transform it to some internal representation. If we're talking about JSON and protocol buffers, things like that. And usually you have to copy some of the data into your internal representation in the process. Ours is 0 copies, so you don't have to make any copies. And using mmap means that we can offload all memory handling to the operating system. These data structures that I mentioned, they usually have arrays with a very large number of items, and we want to make sure that they're as tight as possible. So the first thing that we're going to do is going to get rid of all that extra padding that the compiler adds between items. Then we will carefully reorder the fields in every struct to make sure to get rid of the padding within the struct between different fields. And finally, if any of the fields don't require a full byte for their information representation, for example, Booleans, we'll kind of pack them together into a single field using bit packing. A single byte, sorry. So there's a lot more to cover in terms of data management and other features and performance techniques, and I kind of love talking about this stuff and nerd out about it. So please come over and talk to me later. And also please check out the GenomeKit. We just recently open sourced it. I'm sure it's really fast and easy to get going. Thank you so much.